Once again, welcome to my YouTube channel, Maths with Ease by Mr. Kamotho. And in this video, I want us to explain example 1 in shape and space 8, topic on vectors, and a very simple example. We are told to express vector S as a column vector. Vector S as a column vector. You can say vector S as a column vector. And we always talk about the x displacement and the y displacement. So vector S is moving from here into this direction. You can see the direction of the arrow. So my question would be, what is the displacement along the x-axis? And what is the displacement along the y-axis? And I will see that vector S is actually 3 steps along the x-axis and 4 steps along the y-axis. And that is the vector S in column form as a column vector. That is part A of the question. It's not a fraction and it should be written that way. Part B, find the magnitude of vector S, the size of vector S. Now, the magnitude of vector S, which is S magnitude, we have a right angle triangle, and we can easily use the Pythagorean or Pythagoras theorem and say the size of vector S is actually contributed by the x-axis displacement and the y-axis displacement, meaning that it is the square root of 3 squared plus 4 squared and the root of that, because basically we know what Pythagoras theorem states. If we have a right angle there, and this is A, and this is B, and this is C, we know that A squared plus B squared is equals to C squared. And that is the knowledge we have used here, meaning that we are having the root of 9 plus 16, which is 25, and vector S is 5 units. That is the magnitude of vector S, 5 units. Now, with 5 units, we can easily be able to answer part C of the question, which is asking, calculate the size of the angle X. Calculate the size of the angle X. The size of the angle X. This is where now we can use trigonometry, basic, because we all know about SOHCAHTOA, whereby sine is opposite of a hypotenuse, the cosine of an angle is adjacent of a hypotenuse, and the tangent is opposite over adjacent. Now, according to our original triangle, we have been given the opposite. This becomes the opposite side of that angle, and this becomes the adjacent side of that angle. We have been given the opposite and we have the adjacent. We have the opposite and we have the adjacent. So we can easily now use the tangent of angle X degrees is 4 out of 3. So to get X, we talk about the tan inverse of 4 over 3. The tangent inverse, which is shift tan. The tangent inverse, which is shift tan of 4 over 3. And let us see, we have, this is in radians. Let us first of all put it in degree mode. Degree mode, we have 3. We are now in degree mode. Let's start again. Shift tan of 4 over 3. We have something we can say now we have 53 degrees. There we are, 53 degrees. So X is 53.1 degrees. And that is how we can explain example 1 in a nutshell. And let us meet in the next video. Thank you.